Your daily sales dashboard is timing out, database CPU just hit 100%, and queries are queuing. The culprit: a 12-table Snowflake join running nested loops over millions of rows. Let's explore 3 data modeling approaches: Star Schema, Snowflake Schema, and Data Vault. You'll learn their structures, see SQL examples, and understand when to use each one. Plus, we'll dissect a real production incident caused by a Snowflake schema gone wrong. Data modeling starts with your source systems feeding through ETL into the data warehouse. Choosing the right schema there, Star, Snowflake, or Data Vault, can make or break query performance, storage efficiency, scalability, and ultimately what your BI tools can deliver. Let's start with the simplest: Star Schema. Star Schema has a central fact table surrounded by denormalized dimension tables: customer, product, and time. This structure minimizes joins, making queries fast, and its flat customer dimension is ideal for BI tools like Tableau, while also enabling time-based trend analysis for BI dashboards. We create the tables for a Star Schema. Notice that DIMProduct includes the category directly, no separate category table. The query joins just 2 tables to get sales by category. Without a slowly changing dimension strategy, a direct update overwrites history. To fix it, archive the current price before applying the new one, preserving an audit trail for future analysis. Snowflake Schema keeps a central fact table, fact sales, surrounded by dimensions normalized into subtables: product, category, customer, city, and time. This reduces storage but increases the number of joins, which can slow down queries. We normalize DIMProduct into DIMProduct and DIMCategory, and DIMCustomer into DIMCustomer and DIMCity. The query now needs 3 joins instead of 2, a small example, but imagine if dimensions were split into 10 subtables each. When Snowflake dimensions are deeply normalized, queries can involve many joins, here 12, causing the optimizer to pick nested loop joins that scan millions of rows and time out. The fix uses a single join, avoiding deep normalization and preventing that explosion. Data Vault is highly normalized. Hubs like customer and product hold unique business keys, links represent relationships, and satellites carry all descriptive attributes with history. It's built for auditability and handling many source systems. Data Vault uses hash keys for performance. The query is more complex, requiring subqueries to get the latest satellite record. This model is extremely flexible but demands careful ETL management. Data Vault requires a dedicated ETL framework. Manually generating hash keys with MD5 on literal values can cause inconsistencies. Automate by using SHA2 directly on the column to produce correct, consistent keys. Comparing schemas feature by feature. Star is best for performance, Snowflake for storage, and Data Vault for enterprise integration with full history. Match the schema to your business needs. For real-time dashboards, Star. For archival with limited storage, Snowflake. For enterprise data hubs pulling from multiple source systems with a strict audit requirement, Data Vault. Let's walk through examples of each schema. Notice the differences in structure. Star is flat, Snowflake adds a category table, Data Vault uses hash keys and load dates. You can convert your Snowflake tables into a star-like view by denormalizing with joins. Then, materialize that view for your BI dashboard to ensure performance. This view denormalizes the Snowflake tables into a single flat structure. Queries against it are simple, but beware of performance. Consider materializing the view if you query it often. A standard view recomputes all joins every time it's queried. That's why repeatedly calling select from star sales is slow. For frequent reports, switch to a materialized view like star sales MV, which stores the precomputed result and avoids that repeated work. These best practices help avoid common pitfalls. Design with a star schema for simplicity, use surrogate keys, implement SCD for history tracking, add indexes on foreign keys, and always monitor execution plans to catch bad join strategies early. It starts with a user request. The Snowflake schema normalized dimensions into 12 tables. The dashboard query joined all of them without proper indexes. The optimizer chose a nested loop join that scanned millions of rows per join, maxing out the CPU and timing out the dashboard. When the user request triggered the dashboard query, we created a materialized view that denormalized the most critical dimensions into a star-like structure. We also added composite indexes on foreign keys in the fact table. This eliminated the need for many joins, and the result was a 200 OK response, with query time reduced from minutes to milliseconds. This is the exact pattern that caused the incident. Deep joins without indexes force nested loop scans at 100% CPU, but adding an index on fact sales producted allows index seeks, avoiding those scans. Always add indexes on foreign keys and consider denormalizing. When debugging Snowflake schema performance, start by checking the query execution plan. Look for nested loop joins and consider denormalizing or adding indexes. Use information schema to monitor table sizes and satellite loads for data vault, filtering with something like load date now. Interval 1 day to focus on recent records. Let's review interview questions on this topic. These frequently asked questions clarify common confusions. To summarize, choose star for fast queries, Snowflake to save storage, and Data Vault for enterprise integration. And remember, test with realistic data volumes and monitor execution plans. Thanks for watching. The full article and code examples are covered in detail at thecodeforge.io.